Okay, today's lesson is called Piecewise Defined Functions. So let's start out with what the learning objective is. I can analyze piecewise functions by combining what I know about intervals, parent functions, and transformations. So let's take a minute and decide where we are on the spectrum of the learning objective. If I've never heard of this before, I'm a novice. If I remember how to do this from Algebra 2, I'm an expert. Otherwise, I'm somewhere in between. Okay, so let's start out with the definition. A definition of a piecewise defined function is a function that uses different formulas or rules depending on what values of x are being used. The notation looks like this. So we have multiple expressions and then intervals that are defined. So talking about intervals, we just went through interval notation. So these are my x values. And we write these in set builder notation. Okay, so these have the inequalities. All right, so let's review. So intervals, Some concepts with intervals. Intervals can be used open. So open, we have an open circle. They can be closed. So we show that with a closed circle, or infinite. I show that with an arrow. What intervals do not do is they do not overlap. And the pieces can connect or not be connected. What does that look like? Let's take a look at a couple of these. All right, so here's two examples of some piecewise defined functions. On the one on the left, I have two different functions and I have arrows on the end. So they continue to infinity. So I have two sections. So I have two intervals and I'm looking where I'm changing. So I have one interval defined from here to here and one interval defined from here to here. So when I'm naming these intervals, I'm naming the x values in set builder notation. So the interval to the left is where x is less than 0. I guess it could be less than or equal to. And to the right, I'm greater than or equal to 0. And the equation is linear to the left and it's quadratic that opens down to the right. So these two pieces are connected. The next one shows us two pieces that are not connected. So here is my intervals from here to here and here to here. Oops, I guess the arrow continues. So this continues. These two are defined and there's a spot in between where I'm not defined. So again, I'm using set builder notation. Okay, so let's evaluate using set builder notation. Okay. Evaluate the function at the given interval first by determining which expression to use. So I am deciding which equation to use based on what my value of x is. So I'm looking at the first one where it says p at 1. So I know 1 is in the first interval. So I know I'm going to use the first equation. So I'm going to substitute 1 in for x. So this is going to be 3 times 1 is 3. plus 5 is 8. Okay, where x equals 5, I'm going to put that in the first interval because this is less than or equal to 5. So I'm again using the first interval. So this is going to be 3 times 5 is 15, plus 5 is 20. P at 10, I would be using the second interval. So I'm going to substitute into the second equation. So that is going to be 10 squared, which is 100, minus 4 is 96. And P at negative 6 is not in either interval, so I would say this is undefined. Okay, I'm going to give you a minute. Can you evaluate the next set of functions? Can you pause the video? Okay, so the first one, at x equals 0, I have my first, second, and third. At x equals 0 is going to be in my second function. So this is going to be 0 plus 10 is 10. F at x equals 3 is in my third interval. So I'm going to substitute into the third equation. So 2 times 3 is 6, minus 6 equals 0. F at negative 100. This is going to be in my negative 100, my first interval. I don't really have an x value that's a constant, so I just put number 8. And f at positive 100 is in my third interval. So I'm going to substitute 2 times 100 minus 6 is 194. Okay, let's try a word problem. Okay. So this time I have a word problem and I want to define the equations and the intervals based on the information. You determine your tax credit C based on your annual salary A. If your annual salary is $24,000 or below, your tax credit is based on 25% of the salary. If your salary is between $24,000 and $50,000, the percent drops to 20%. And if you make more than $50,000, the credit is 14% of the annual salary. So when I'm talking about percents, I talk in percents, but I use decimals. So the first percent was 25% of my salary, so that's 0.25. And my annual salary is A. And it went down to 20% of A, and then down to 14% of A. So writing the intervals in set builder notation, it said if my salary is 24,000 or below, so I'm going to say 0 is less than A is less than or equal to 24,000. Next, it said if I am between 24,000 and 50,000, so I am not including 24,000 and not including 50,000. And then if I am greater than 50,000, so A is greater than or equal to 50,000. Okay, so I just take it in steps. Okay, so this is a word problem. So now let's do an example where I give you a graph and you need to tell me the equations and the intervals. Okay, so we have linear equations here. So I'm going to use what I know from linear equations. in general, I know the equation for the formula y equals mx plus b, where m is the slope and b is the y-intercept. So I'm looking at my sections here. Here is one section, one interval from here to here. Just dividing up my graph. Here's my second interval from here to here. And here's my third interval. So to define my intervals, I'm going to name my x values. So here's my x value. My first x value is, this is negative infinity, right? And this is 2, but we're writing it in set builder notation. So I want to say x is less than or equal to 2. And I said equal to because I have a filled in circle. My next interval, I'm between 2 and 5. So I'm going to say 2 is less than or equal to x is less than or equal to 5. And then my third interval, I'm greater than or equal to 5. Okay, so I'm just naming my intervals based on the x coordinate. So now I want to write some equations. Okay, so taking a look at the middle equation, I see that's a horizontal line. That's going to be y equals 5. I got that one. For the first interval, so I see my y-intercept is -1, and my slope is rise over run. Oops. So slope is rise over run. So this is rise is 1, 2, and run is 1. So the slope is 2 over 1, and my y-intercept is 1. So substituting in my equation, I get y equals 2x plus 1. I'm going to do the same thing for this equation, or for this line. I want to know what the slope is. So slope is rise over run. So if I'm going to start here, rise is 1, 2, and run is 1, 2. So 2 over 2, which is 1. And my y-intercept, so if I keep going backwards, this is 2 up here, so 7, 8, 9, 10. So b is 10. So substituting, my slope is 1 and my y-intercept is 10. This is, I'm sorry, you know what? This is, I went backwards, so it's a negative. So this is a negative slope. So negative x plus 10. And then, of course, we want an example of doing it backwards, where I'm going to give you the equations, and now I'm going to have you draw them. Okay, so here's the first one. So we're going to, so I know I have 2 parts to my graph, and they switch at 3. So I know this is where I'm switching, is at x equals 3. So I'm going to rewrite this first equation in y equals mx plus b form. So this is really minus 2x plus 7. So I know the y-intercept is at 7, so I want to start at the y-intercept. And my slope is 2 down and 1 to the right. So I know I'm going to go down 2, 1, 2, and 1 to the right. 1, 2, 1 to the right. 1, 2, 1 to the right. And I'm looking, and it says it is open. So I'm drawing in my line. And then G equals 1 is a horizontal line, and it includes 3 this time. So here's my horizontal line. Okay, so I just take it one piece at a time. Let me try the next one. Okay. Okay, this time I have two linear equations and a quadratic equation. So I see I am x is less than or equal to 0. So here is where an interval is from here to here. Then from 0 to 3 is another interval from here to here. And then greater than 3, so from here to here. Okay, so I'm going to start out with the middle one. That is from 0 to 3 is a horizontal line of 4. And it does not include 0 and does not include 3. So horizontal line with open circles. Got that one done. For greater than or equal to 3, I have linear equation where my slope is 1 and my y-intercept is 1. So I'm starting here, but I'm not in the middle section, so I'm not going to plot it. So I have a slope of 1, so I'm going up 1 and to the right 1, up 1 and to the right 1, up 1 to the right 1. And this time it says it includes it, so I'm going to fill in this circle and keep going. So up and to the right. So this equation goes here. So even though I use the middle to help me get to where I need it, it's only in the section greater than or equal to 3. And then my final graph is a parabola, but it's not the whole parabola. So I know if I pick the point 0, 0, I'm right here. And if I pick the point -1, y is 1. And I pick the point -2 and y is 4. So I got the general shape here. So here we go. Okay, where are we on the lesson? Can we revisit? Do you feel that this jogs some memory and what's some practice? And my goal is to be an expert by the end of the lesson.